Now we're going to take a quick look at vector subtraction. So far we've just been adding vectors. So if we had this vector A and we had our vector B, so to add those together we would just pick up vector B and put it on the end of vector A like that, and our resultant would go from the tail of A to the head of B. And what if we wanted to subtract those vectors instead of adding them? Well, if you've got vector A again here, and you've got vector B here, to subtract B from A, you need to add the negative of B. And that's similar with numbers. If you had 5 minus 3, what you're actually doing there is you're taking 5 and you're adding negative 3. And here we want to take B and find its negative. How do we get the negative? Very easy, we just draw the head on the other end. And then we get our rubber and rub the head off that end. And that is now minus B. And now we need to pick this up and put that one on A, just like we do when we add them. So we pick that up, we move it over, but we can't just put it like this, because then those vectors are head to head. So we need to put them head to tail, and that means it needs to come over here. And now you can see that our resultant going from the first tail to the last head is actually like this. So this is A plus B, and this one is A minus B. And you can see the result there is very different. Don't forget that when you're subtracting vectors like this, you're simply adding the negative. I should write that, so hopefully you'll remember it. You're adding the negative. So if this is B, then this is minus B. You just flip it around, and then when you add those together, don't forget you have to add head to tail, just like we did before. Next we're going to look at using vectors as forces, and vectors are extremely useful when thinking of forces, because if you imagine you've got an object here and a force acting on it, that's very clear, isn't it? You've got an object and the force comes in just like an arrow and bashes into it. So how do we extend that for use with multiple vectors? Well, say we've got our mass here, a little sphere, and we've got one vector acting this way, and we'll call that vector A, pushing on our sphere. And then we've got vector B pushing on it this way, and that's vector B. Now which way is our mass going to go? Well, if you look at it, it might go this way if A's a bit bigger, it might go this way if B's a bit bigger. If those forces balance, then it may even go straight up here. Not quite sure yet. So what we need to do is, remember when we were adding vectors, we needed to add them from tail to head, or from head to tail. So we need to pick up one of these vectors and move it onto the other one. Now you can move either one, but let's move vector A, and we'll move it like this. And then when we draw our resultant, we can see that it's going to go like this. So if we pick up our vector A again and put it back where it was, and then we pick up the resultant that we found and put it here at the center of our mass, we can see exactly how those forces are going to affect that mass, and they're going to kick it off almost straight up and a little bit off to the left. And of course, if we had a precise question about this, I'd have to tell you these angles as well as the magnitudes of these vectors, and then you could calculate this vector, its size and its direction, using either your graphical methods or trigonometry. So that's how we use vectors as forces. And of course, if you've got a little mass here, then you can have as many vectors as you want pushing on it. You may even have some vectors pushing this way and some vectors pushing this way. You can have forces of different sizes coming in from all different directions. And this method of vector addition will tell you what the total force, or the net force, is on that mass. This is a very important concept, which we actually call the summation of forces, and this is something that you're going to be learning about in more detail very soon. If you have A, for example, is force 1 and B is force 2, then R up here becomes the sum of your forces. That's meant to be a little I there. So this is the summation of all the forces acting on this mass to give you the net force that tells you how the mass will react.